Okay. All right, so exponential and logarithmic equations we're going to be talking about in this lesson. We're going to get through part of it today, and then the other part, whatever we don't finish, we'll finish up on Monday. Remember, your quiz tomorrow is just over 4.1 to 4.3, so that's up to through everything we did yesterday. So this stuff is not on your quiz tomorrow. Also, a reminder about the quiz, basic calculator, individual, open notes. So just make sure you have your 4.1 to 4.3 notes, how you want them, ready to go, and then you can use those tomorrow. All right, Newton's law of cooling is a formula that we're going to use. Now, I'll talk about in a second what it means. There are two versions of the formula here. They are the same formula. One's just written with logs and one's written with exponents if we like solve for a different variable. So what I want you to write down, see if my magic pen will work maybe. Let's see here. Let's see. Did that do it? Nope. Oh, there it goes. Yay, write that down. Okay, Newton's law of cooling. And we're going to write down the logarithmic form of it. Okay, so what does this formula do? So Newton's law of cooling talks about if I take an object that isn't a temperature of the room it's placed in, Newton's law of cooling will graph how the temperature of that object changes. So common examples are you take something that's hot out of the oven and you put it on the counter, it will slowly cool to eventually room temperature. It starts cooling really fast and then it kind of like levels out. Or vice versa, if I take like an ice cube and I put it on my counter, it's going to slowly warm up to the temperature of the room, which is why my ice cube melts. So that's what this function is used for. You need to know what the different variables stand for. So T sub 0 represents starting temperature. Anytime we see that sub notation of 0, it means an initial of something. Okay? And all the capital T's here mean temperatures. T sub S is here twice, and that the S means surrounding. It's our room temperature or our environmental temperature. Okay, so that's what TS is. It's our surrounding temperature, room temperature, environmental temperature. And then K is our growth rate, like it was with our other formula, so that's something we'll be solving for. T of T and then little t go together. That's why you see a little t in both of them. This is, little t is a time, and T of T is a temperature at that time. Okay, so that's a point that goes together. So T sub 0, room temperature, T sub S, oh, sorry, initial temperature. T sub S is room temperature, little t and T of T are temperature at a certain time. And then K is something that we solve for. All right, everybody have it written down? All right, let's do an example. Here's my example. So, the local McDonald's franchise has discovered that when coffee is poured from a coffee maker whose contents are 180 degrees Fahrenheit into a non-insulated pot, after 1 minute, the coffee will cool to 165 degrees Fahrenheit if the room temperature is 72 degrees. How long should employees wait before pouring the coffee from this pot into customers to deliver it at 125 degrees? Okay, so this is like, how long should we wait to give somebody coffee that's like not going to burn them so they don't sue McDonald's, right? So it's a real life situation. Somebody did that. When was that? Like the 90s? Somebody did that? She like spilled on her lap. I think she won. Because they didn't. Oh, did she lose? I mean, only. I think it was 70 or 75. Sounds like a win. Well, she didn't have 30-degree burns on her. She had burns on her lap, and it was because they didn't label the coffee hot. So that's why you guys ever see, like, when you get coffee or something, it'll say, like, caution, contents hot. It's because of that. That happened in the 90s, yeah. Okay, so I'm going to write my formula down one more time here. Natural log T of T minus T sub S T sub 0 minus T sub S equals negative KT. When we use this formula, we actually are going to use it twice, okay? So the first time we're going to use it to solve for K. So we're going to plug in everything we can. Do we have a starting temperature of the coffee when it is freshly brewed? What is that? 180, okay? Do we have a room temperature? 72. Okay. K is not something you're ever going to know. We're going to solve for it. So the last piece we're missing are these two values that go together, a time and a temperature at that time. Do we have a time and a temperature at that time? Maybe? Yeah, so 1 minute elapsed, 165 is the temperature. Make sense? That those go together always. Okay, everything on the left side is just stuff you can put in your calculator. If I do 165 minus 72, I get 93 on top. On the bottom, I'm going to get 108. On the other side, negative K times 1 is just negative K. How do I solve for K? How do I get rid of that negative? Multiply or divide by negative. Okay, so that's all you have to do. Is we're going to take the negative natural log of 93 over 108. And I get 0.1495. Okay, good? All right, so now we're going to use the formula one more time to solve for what we're actually looking for. Certain things will never change. What's never going to change is your starting temperature, 180, and your room temperature. In this case now, I know what K is, so I'm going to put negative 0.1495. And now your variable is going to be, what are we solving for here? It said, how long should employees wait to deliver it to temperature or to customers at 125 degrees? So we're solving for the time, we're solving for little t, when the temperature is going to reach 125. Again, that's my pair that goes together. So again, everything on the left is just something you're going to plug in your calculator. 53 equals negative 0.1495t. Don't forget the negative. It's part of the formula. It always goes in front of that K. And then how do I solve for t? Yep, divide by negative 0.1495 on each side. So again, that's all just in your calculator. So natural log of 53 over 108 divided by negative 0.1495. And I get about 4.76, and time here was measured in what? What would I label it? Minutes. So let's pretend you were the manager at McDonald's and you had to tell your employees how long to wait before serving the coffee to customers. Would you tell your employees to wait 4.76 minutes? Likely not. What would you tell them? You would round it up, not down. So you would probably say 5 minutes would make it a safe enough temperature to be served. Okay? That's Newton's law of cooling. Any questions? Cool. All right, moving on. Let's solve a couple exponential equations to start. In some cases, you're going to get lucky where on both sides of your equation, you can write those bases as the same base. Like if I had a 2 and a 4, those are both powers of 2. Or if I had a 3 and a 9, those are both powers of 3. So occasionally we get lucky and our bases can be written as the same base. So here, 3 and 243 are both powers of 3. If you're not sure what power of 3 243 is, you could guess and check with your calculator a little bit. 243 is 3 to what power? It's 3 to the, what is it? 5th. Yep. Okay, so I just rewrite that number as 3 to the 5th. Once you get the same base on both sides, you can actually then just compare the exponents. If 3 to the x power equals 3 to the 5th power, the only way for that equation to be true is if x equals 5. Okay, so this is a way of avoiding using log. We don't have to use the log because we can use a common base instead. All right, so let's look at the next one. 8 to the x equals 4. 4 and 8 are both powers of what number? 2. 8 is 2 to what power? 2 to the 3rd, and that 3 is multiplied by an x. This is a power to a power property, so it's going to be 2 to the 3x. And then on the other side, 2 to the 2nd. As soon as you have the same base, we've got 2 to the 3x equals 2 squared. The only way for this equation to be true is if those exponents are equal to each other. So 3x must equal 2. So x must equal 2/3. Answer. You with me? Good? Okay. 4 and 128 are both powers of what? 4 is 20. 128 might be a power of 4. 4 to the 3rd is 64. 4 to the 4th is 256. So if I can't use a 4, what am I going to use? 2. So 4 is 2 squared, and again, that 2 in the exponent is multiplied by the absolute value of x power to a power. 128 is 2 to the 7th power. So again, my exponents must be equal to each other. How do I solve for x? It's an absolute value equation. We've done those. What do I do? We did them on our last test. Come on, don't tell me you forgot. We got an exam. This stuff's coming up again. We can't forget it. Divide by 2, get the absolute value alone. So 7/2, or you could say 3.5. And then how many answers is this going to have? What are my 2 answers? Plus and minus, either 7/2 or 3.5. Questions there? Common base. All right. Let's try some other ones. See what happens when they get a little more complicated now. 9 to the x equals 3 to the x plus 1. My bases are powers of 3. Okay, so 9 is 3 to what power? Okay, so I can write 3 to the 2x equals 3 to the x plus 1. Everything's powers of 3. So now what can I say must be true? The exponents must be equal. All right, and then you just have a linear equation to solve now. So how would I solve for x here? Subtract x, which would just give me a 1x equals 1, and that is actually my answer. Could I check this answer, by the way? I mean, sure, it's an equation. Just plug it back in, right? 9 to the 1st, that's 9. 3 to the 1 plus 1, so 3 squared, also 9. It checks. Okay, let's try another one. I have 3/5 to the x equals 125 over 27. Can I rewrite those bigger numbers as powers of something instead? 125 is a power of what? Okay, so that's 5 to the 3rd. What about 27? That's 3 to the 3rd. Okay, this is looking better. I'm trying to make it match that other side. You can write it like this, 5 over 3 to the 3rd. That's what we do with an exponent. If it's in a fraction, we distribute it to the top and the bottom. So you might actually be able to just solve it now. Our bases aren't the same, but could you see what number we could put in to that exponent that would make it equal what we see on the right there? Yep. Yeah, so we need a 3, but we also want our fraction to flip, and that's what negative exponents do. So our answer is going to be x equals -3. Yep. Okay, last one. I have more bases in this problem. 3, 9, and 27 are all powers of 3. Okay, so the first one I'm good. I'm going to keep that the same, 3 to the x. 9 is 3 to a power. Yep, so that 2 is multiplied by that whole thing, x minus 1, so we need a parentheses. And then 27 is 3 to what power? 1 minus 3x. Okay, here's the biggest mistake people make when solving these problems. At this point, they stop and compare the exponents. You can't do that yet. You need a base to a power equals a base to a power. There's too many bases still on that right side. So we need to take that right side and push them together. So you need to know your exponent rules. If I have 2 bases that are the same and they're multiplied, what do I do with their exponents? Add them together. What if they were divided. What do I do with their exponents? Subtract. Okay, so that might come up on your homework. So I'm going to keep the base of 3, but I'm going to combine them together and add the exponents. So 2 parentheses x minus 1 plus 3 parentheses 1 minus 3x. Only when you have base to a power equals base to a power are you now allowed to compare those exponents, apples to oranges, right? Okay, so on the left side I have an x. On the right side I have all this stuff that I'm going to have to kind of filter through here. All right, so I definitely have to distribute. My 2 will give me a 2x minus 2. My 3 will give me a 3 minus 9x. And now I'm going to combine like terms. 2x minus 9x gives me negative 7x. Negative 2 plus 3 gives me a positive 1. Add 7x, that'll give me 8x equals 1. So x equals 1/8. Here's our final answer. All of these problems you can also solve with logs. The first 5 that we did aren't actually too terrible with logs. This last one is real bad if you want to use logs to solve it. So always look for this first. If you have that common base, it's going to really be the simpler way to do it. And then we'll talk about in a second what happens if you can't get a common base, then we have to use logs. Okay? Any questions on any of these exponential equations? All right, moving on. Okay, so let's say I have this situation, right? So I've got 5 to the x equals 3. 5 and 3 I can't write as a power of something that would be the same. So this is where we have to use logs. And we know we have to use logs because we are solving for an exponent. Remember, that's how we introduced logs before Thanksgiving break. Why do we have a log? Because we're solving for an exponent. If you have an exponent that you need to solve for, we're going to follow the steps at the bottom here. I'm going to do it with the problem at the top so you can see an example. First thing we're going to do is isolate the exponential expression. So that 5 to the x is what we call the exponential expression. We don't want anything added, subtracted, multiplied, or divided by it. If there were things added, subtracted, multiplied, or divided by that 5 to the x, we want to move them to the other side first. Once it's isolated, like what we see there, we're going to take either a common log or a natural log on both sides. You can actually use any log base you want, but we're going to stick with the common log and the natural log because remember those are buttons in our calculator, so that's going to let us use our calculator to solve. So I'm just going to use the common log, log, base 10 if I want to write the base in, and I'm going to use that on both sides. The reason we use a log is because now we can use the log properties that we learned in the last section. Log properties say if I have a log and I have an exponent within that log, what can I do with that exponent? Bring it down in front. There has to be a log there for you to use that property though, okay? Now some people at this point, their head will start to spin, but log 5 and log 3 are just numbers. You can type those in your calculator. So if I want to solve for x, all I have to do is divide by log 5. And that's what you're typing in, okay? And make sure if you're using a red calculator, you end the parentheses after the 3 before you divide by log 5. And then you can round to however many decimal places. Log 3 divided by log 5. I get, if I give it 3 decimal places, 0.683. Now, it's approximated. You can plug it back in to check. That means if I rounded my answer, I'm not going to maybe get exactly 3 when I plug it back in, but I'm going to get really close to 3. Okay? Any questions on that? We're good? All right. Let's practice a couple. Let's try these two. 5 times 2 to the x minus 3 equals 17. All right. First thing I need to do is isolate the exponential expression. So that 2 to a power, I need to get it by itself. What do I need to move to the other side? 5, so I'm just going to divide by 5 on each side. So 2 to the x minus 3 equals, I'm just going to leave it exact. I'm not going to round unless I have to, 17/5. As soon as you've got your base alone, we can now introduce the log into the equation. So I'm going to take the log on both sides. Log of this equals log of this. And because I took a log, what am I allowed to do with my exponent? Bring it down. x minus 3 times log 2 equals log 17/5. And this looks nasty, but remember log 2 and log 17/5 are just numbers. So the next thing I'm going to do is just divide by log 2. Trying to get that x alone. So now I have x minus 3 equals, that's what I'm using my calculator for. And you can use natural log 2 or you can use common log and get the same answer either way. Log 17/5, end your parentheses, divided by log 2, and I'm going to round to 3 decimal places, 1.766. Last step, add 3, 4.766 is my final answer. Plug it back in to check, make sure it works. Let's try the next one. What if I have 2 powers in my problem? 5 to the 2x minus 3 equals 3 to the x plus 1. Okay. My bases are both alone. That's good. I don't have anything to move over. I'm going to take the log of both sides. Log 5 to the 2x minus 3 is log 3 to the x plus 1. Now, both exponents are going to move down. 2x minus 3, I'm going to keep that in parentheses so it stays together, times log 5 equals x plus 1 times log 3. Okay, good so far? Following me? All right, remember log 5 and log 3 are just numbers. So at this point, I'm just going to divide by one of them. It actually doesn't matter. I just need to like move one of them to the other side. So I'm going to kind of do what we did in the last problem and divide by, what I see on the left there. I'm going to divide both sides by log 5. Okay, on the left, they're canceling. Just leaves me with 2x minus 3. On the right, I have x plus 1, and I'm going to reduce now the log 3 divided by log 5. That's what I'm going to type in my calculator. This is where we're going to get a decimal. Log 3 over log 5 is 0.683, and I'm just going to put that in front of my parentheses. So now we just have a linear equation. I'm going to distribute. So I'll have 0.683x plus 0.683. Then I need to get my x terms together. So I'm going to subtract 0.683x on each side. So 2 minus 0.683 gives me 1.317x. This is just kind of gross with all the decimals, but I mean, nothing crazy as far as like solving steps go. Minus 3 equals 0.683. Add 3 to the other side. We get 3.683, and then last step, divide. And I get 2.797 if I give it 3 decimal places. Okay, you can plug it back in, both sides of the equation. We'd have to plug it back into to make sure we get a true statement. Yes?
You're putting log 5 under the entire equation. Why don't you mess the x plus 1 in the parentheses?
So if it was addition between those two terms, I would divide it into both terms. But because it's a product, it's all actually the same term. So I only have to divide it in once versus 2 separate. Or if it was subtraction even, I would have to divide it into everything. Okay. All right. One more of these. 2 times 3 to the x minus 1 equals 5 to the x plus 1. Okay, so first step is I want to get my base alone. And we have 2 bases here. The problem is one of them's already alone, but the other is not. And even if I move the 2 over, then I'll have the same problem, right? One will be alone and one isn't. So we just kind of have to deal with it. So I'm going to take the log of both sides to start, because at least I have one base alone. That's all inside that log there. Equals log of 5 to the x plus 1. I can bring the one on the right down, but the one on the left I can't bring down yet because those terms aren't separated. So we're going to use one of our log properties. Our log property said if we have multiplication and I want to expand it, if I want to separate it, I can turn it into what operation? Addition. So I can make this log 2 plus log 3 to the x minus 1. So this is like worst case scenario if I can't get that base alone. Now I can take both of my exponents and move them down. So log 2 plus x minus 1 times log 3 equals x plus 1 times log 5. So this is really just a linear equation. Now it looks kind of messy with all the logs, but all the logs have numbers next to them, which means they are numbers. So now you can pick any of these logs to divide by. So let's talk about what Addie was saying a second ago. She said if I divide, like let's say I divide by log 5. In the last problem, I really only had one other term on the other side. Now I have 2 terms. So I have to divide both of them by log 5 here, okay, because of that addition or even a subtraction. I have to do that same thing. So I got a couple of things to type in my calculator. Log 2 over log 5 gives me, I'm going to give it 3 decimal places, 0.431. Then I have x minus 1 that's going to get multiplied by whatever log 3 over log 5 is, 0.683. And then on the other side, my log 5s are just canceling, leaving me with x plus 1. So that makes it a little prettier once I divide by one of those logs. All right, distribute 0.6833 x minus point. My computer's getting mad. I'm talking too long. I guess this is going to be our last problem. Equals x plus 1. There we go. Combine like terms. So 0.431 minus 0.683. I get negative 0.252 plus 0.683x, that's a 6, equals x plus 1. Then I am going to, I don't know what I want to do. I'm going to add the 0.252 over. So 0.683x equals x plus 1.252. Put that over there. I need to get my x's together. Remember that x is a 1x. So I'm just going to subtract 1x on each side. So 0.683 minus 1 gives me negative 0.317x equals 1.252. Last step, divide. 1.252 divided by negative 0.317. I get x equals negative 3.9495, so 0.950 if I give it 3 decimal places. Then you can plug it back in, make sure it works. Okay. So this lesson, the 4-4 lesson, is exponential equations, and I think that was actually the last one anyway. We'll do the compound interest problem next week. But all of the exponential equations you guys can do on the homework if you want to start your 4-4 Math Excel. On Monday then, we only have a couple slides to finish up. So we're going to do one problem with compound interest, and then there's a couple equations that are log equations. So if you're working through the Math Excel, just skip over the equations that have a log in them. That's what we're going to cover together on Monday, but everything else you can pretty much do if you want to get started on it, okay? So couple reminders. For 3 Math Excel is due tonight, right? Okay, so if you're finished 4-3, you're doing that tonight. For 4 Math Excel is due on Tuesday next week. So we'll finish the lesson together on Monday when I'm back, and then Tuesday, and that'll be your last Math Excel. These are the last 2 Math Excels. This is it. So here are all the dates that are coming up then. So last Math Excel, due Tuesday next week. Quiz tomorrow. I'm not going to be here like I mentioned. Mrs. Benson will be here. You guys know Mrs. Benson, right? Older lady, short hair, dresses real cute. Okay, so she'll help you tomorrow. Make sure individual, open note, basic calculator. I'll make sure this calculator's in here for you. You guys will have all that. Then Monday we'll finish the lesson, and then we're getting ready for our last test next week. So next week on Tuesday and Thursday, we're going to complete test review together. It's already on Polaris. I'm pretty sure I published it already. So if you want to look ahead at getting ready for that last test, you can. And then next week on Wednesday and Friday will be the last 2 tests that we take. And then that final week, we're going to start getting ready for our exam. I did put on the board for you guys, our exam is that Tuesday, the very last day before break. We're going to be in P100, and you're going to be in there with my 8th period class as well. So there's going to be a bunch of us in here. And it is in the morning that day. It is first, second, and part of third period. You will be missing first, second, and part of third period that day. And I'll be sending a note out to your teachers when it gets a little closer, but just so you can kind of like plan ahead that's happening. I don't think you're going to be doing a lot because you'll be done with exams and all those classes already, but I'll let them know just in case. Okay? Questions for me over any of this stuff? All right, rest of the period is yours. I'll do cell phone lotto. And then good luck on your quiz tomorrow. Last quiz. If you have your phone and the cell phone lotto, you won. Congratulations. Circuit training's due on Monday. I think it's the easiest circuit training we've had all semester. If you haven't grabbed one, it's a great opportunity to earn a ticket for your last test.